In this video, I'll discuss some concepts related to probability. You all know there are 52 playing cards. You need to understand this classification to solve questions of probability related to playing cards. There are 4 suits of 13 cards each, which are spades, clubs, hearts, and diamonds. Out of which 2 suits, spades and club, are of black color, and the remaining 2, diamonds and hearts, are of red color. So, there are 26 black colored cards and 26 red colored cards. Each suit will have the following 13 cards. Okay, this is for each suit. The cards will be, first one is ace, then 2, 3, 4, 5, 6, 7, 8, 9, 10. Then jack represented by J, also called as knave. Then queen represented by Q and king represented by K. These 2, 3, 4, 5, 6. These are called numbered cards up to 10. Okay. And jack, queen, king are called as face cards. So number of face cards in each suit equals to 3. Okay. And there are 4 suits, so total number of face cards in a deck of 52 playing cards equals to 3 into 4, that is total 12 face cards. The following probabilities are asked. Probability of black and queen. Okay. Now there are uh, 2 black queens, one of spade and other of club. Okay. So, and possible outcomes in every case is 52 because there are 52 playing cards. Okay. 2 queens, one of spade and other of club. Probability is 1 by 26. Now probability either black or queen, that means the card can be black as or queen. So there are 26 black cards. These 26 black cards already include 2 black queens, and there are 2 more queens of red color. Okay, because there are total 4 queens, 2 are included here, and you have to add the remaining 2. So total number of favorable outcomes are 28. So probability will be 28 by 52, that is 7 by 13. Now neither black nor queen, that means the card should not be black and also it should not be a queen. So firstly remove 26 black cards, so remaining 26 red cards. In these 26 black cards, 2 queens have already been removed, but 2 queens are still remaining which are of red color. So remove these 2 queens of red color. So total number of favorable outcomes will become 24, sorry here 52, and possible outcomes are 52. So probability will be 6 by 13. Okay. Now tree diagram. If a random experiment consists of 2 or more stages, we can use a tree diagram to represent the process. Suppose take an example, 3 unbiased coins are tossed. Now total number of outcomes is 2 multiply 2 multiply 2. Okay, here 2 is the number of outcomes when a coin is tossed, because there are 2 possible outcomes on tossing a coin. One is head and the other is tail. Okay, so possible outcomes are obtained by multiplying outcomes for each individual trial. Okay, so 2 into 2 into 2 equals to 8. If the coin was tossed 2 times, then number of possible outcomes would have been 2 multiplied 2 equals to 4. Also consider one thing, tossing a coin 3 times or tossing 3 coins at a time are both considered as same experiment. Okay, because their outcomes, possible outcomes, are same. Okay, now this is the tree diagram. Suppose the first coin shows head, then the second coin can show either head or tail. Okay, suppose first coin shows head, second coin also shows head, then the third coin again can show any of the following outcomes, either head or tails. Okay, so the outcomes will be head, head, head. Okay, then this is head, head, tail. This outcome will be third outcome, head, tail, head. Okay, see these branches, head, tail, head, then head, tail, tail, H, T, T. This outcome will be tail, head, head. This outcome will be tail, head, tail, then tail, tail, head, and then tail, tail, tail. These are the 8 possible outcomes on tossing a coin 3 times or tossing 3 coins at the same time. Now find the following probabilities. Probability of getting 3 heads. Now observe the outcomes. There is only one outcome satisfying this condition, okay, which is having 3 heads. So probability of getting 3 heads equals to number of favorable outcomes, that is 1, divided by total number of outcomes, that is 8. Now probability of getting 2 head and 1 tail. Okay, now consider the outcomes which are having 2 head and only 1 tail. Okay, observe these 8 outcomes. Okay, this outcome having 2 head and 1 tail, this one having 2 head and 1 tail, this one having 2 head and 1 tail. So there are 3 outcomes satisfying this condition which are having 2 heads and 1 tail. So probability will be 3 by 8. Okay, now find probability of getting at least 2 heads. See, at least 2 heads means there can be 2 or more than 2 heads, but not less than 2 heads. So consider the cases where there are 2 or more than 2 heads. Okay, observe these 3 outcomes have 2 heads, and you can include one more outcome having 3 heads. So total number of favorable outcomes will be 4 divided by total number of possible outcomes 8. So probability will be 1 by 2. Okay, which are the favorable outcomes here? HHH, HHT, okay, HTH and THH. These are the 4 possible favorable outcomes here. Second is probability of getting at most 2 tails. Now see, at most 2 tails. At most means there can be 2 or less than 2 tails. 2 or less than 2 tails, but cannot be more than 2 tails. Okay, now find the outcomes having 2 or less than 2 tails. Here uh, leaving only one outcome having 3 tails, all the outcomes satisfy this condition having 2 or less than 2 tails. Only this outcome is having more than 2 tails. So here the number of favorable outcomes are 7 divided by total number of outcomes 8. So probability will be 7 by 8. Okay, now 2 fair dice are rolled. Okay, total number of outcomes in this case will be 6 into 6. Number of outcomes in each individual case multiplied together will give total number of outcomes as 36. Also consider here throwing a die twice or throwing 2 dice simultaneously are treated as the same experiment. That means these both will give same set of possible outcomes. Now see the possible outcome. The first outcome is 1 comma 1. That means both the dice show 1. Then first die show 1 and the second die show 2. Similarly 1 comma 3 is another possible outcome. 1 comma 4, 1 comma 5, 1 comma 6. Then 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 5. We have to complete this table to get the possible outcomes. 3 comma 1, 3 comma 2, 3 comma 3, 3 comma 4, 3 comma 5, 3 comma 6. Similarly 4 comma 1, 4 comma 2, 4 comma 3, 4 comma 4, 4 comma 5 and 4 comma 6. Then 5 comma 1, 5 comma 2, 5 comma 3, 5 comma 4, 5 comma 5 and 5 comma 6. 6 comma 1, 6 comma 2, 6 comma 3, 6 comma 4, 6 comma 5 and 6 comma 6. So these are the 36 possible outcomes when 2 fair dice are rolled. Okay, now you have been asked probability that both dice show same face. So there are only 6 outcomes where both dice show the same face, that is 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5 and 6 comma 6. So probability is equals to 6 by total number of possible outcomes 36, that is 1 by 6. Now probability both dice show different faces. So exclude these 6 outcomes Now remaining outcomes are 30 by 36. In all these 30 outcomes, both the dice are showing different faces. So probability is 5 by 6. Now consider the sum of numbers on both the dice. The minimum sum of numbers on both the dice will be 2. Okay, this will come in the outcome 1 comma 1. Only one outcome will have sum 2. So probability of such sum is equal to 1 by 36. Now getting a sum of 3, here two favorable outcomes will be there, 1 comma 2 and 2 comma 1. So probability 2 by 36. Similarly, getting a sum of 4, there will be three possible outcomes, three favorable outcomes, 1 comma 3, 3 comma 1 and 2 comma 2. So probability 3 by 36. Similarly, for getting a sum of 5, there are four favorable outcomes. So 4 by 36. Now getting a sum of 6, 5 by 36. Now completing this table, 6 by 36, then 5 by 36, 4 by 36, 3 by 36, 2 by 36. There is only one case in which the sum of numbers is 12, which is 6 comma 6. Its probability will be equals to 1 by 36. Okay. Now you are required to find probability of getting a sum greater than 9. For getting a sum greater than 9, include these three cases. Okay, that means the sum can be 10, 11 or 12. So you have to add probability of 10 plus probability of 11 plus probability of 12. Okay, so 3 plus 2 plus 1 divided by 36. So 6 by 36 equals to 1 by 6. Now you have been asked the probability of getting a multiple of 2 on one die and a multiple of 3 on the other. Here it is not specified whether multiple of 2 will come on first die or on the second die. So we'll have to consider both the cases. Now consider the outcomes where there is a multiple of 2 on first die and a multiple of 3 on the second die. The following cases will be 2 comma 3, 2 comma 6, 4 comma 3, 4 comma 6, then 6 comma 3, 6 comma 6. Now consider the cases where there is a multiple of 3 on first die and multiple of 2 on second die. So 3 comma 2, 3 comma 4, then 3 comma 6, 6 comma 2, 6 comma 4. Now 6 comma 6 is already included here. So total number of favorable outcomes are 11. Now probability will be equal to 11 by 36. Okay. Now probability of getting the sum as a prime number. Here in the sum there are 5 prime numbers, 2, 3, 5, 7 and 11. Now adding all the favorable outcomes, we get, now favorable outcomes for 2 is 1, then for 3 is 2, then for 5 is 4, for 7 6 favorable outcomes, and for 11 there are 2 favorable outcomes. Okay, so total number of favorable outcomes are 15 divided by 36. So probability is equal to 5 by